Stop on a dime. An advertisement claims that a particular automobile can stop on a dime. What net force would be necessary to stop a 850 kilograms automobile traveling initially at 45 kilometers per hour in a distance equal to the diameter of a dime, which is 1.8 centimeters? Okay, so basically I'm going to decelerate to stop in this distance, so I have constant acceleration motion which is starting at t is equal to 0. Okay, and this acceleration, constant acceleration, will be equal to the change in the velocity delta v divided by delta t, which is the final velocity will be 0. Initially I have 45 kilometers per hour, so 0 minus initial speed 45 times 1000 meters, and 1 hour has 3600 seconds. This divided by the final time tf. So if you calculate this, we obtain minus 12.5 divided by the final time tf. The velocity as a function of time will be equal to the initial speed 45 times 1000 meters divided by 3600 seconds plus at. So this is going to be 12.5 plus at, and the distance we travel, delta x, is going to be equal to integral from 0 to final time tf v of t dt, and this is integral from 0 to final time tf 12.5 plus at dt, which is 12.5 final time plus 1 over 2 a t final square. So if you substitute here 12.5 t final plus 1 over 2, acceleration is minus 12.5 over t final times t final square. This is going to be 12.5 parentheses 1 minus 1 over 2 t final, which is 6.25 t final. And what is this displacement equal to? It has to be the diameter of a dime, 1.8 centimeters, so it's 1.8 times 10 to minus 2 meters. So that is the requirement, or that's actually what is suggested by the advertisement. So 6.25 t final is equal to 1.8 times 10 to minus 2 meters, gives us t final to be 2.88 times 10 to minus 3 seconds. So in about 2.9 milliseconds it's going to stop. So we can calculate the acceleration. Acceleration is minus 12.5 divided by t final, so it's going to be a deceleration, 2.88 times 10 to minus 3. And the net force that we have to apply to cause this deceleration is mass of the car times acceleration of the car. So we have 850 kilograms times the acceleration minus 12.5 deceleration divided by 2.88 times 10 to minus 3 seconds. So therefore we need a force which is minus 3.69 times 10 to 6 newtons, up to 3 significant figures. So this is the force we need. It's negative because it's deceleration. And basically my conclusion is that in order to achieve this task, a very large force is needed. Okay, so let's summarize what we did here. We have an advertisement that claims that a particular car can stop on a dime. That means in a distance equal to the diameter of a dime, 1.8 centimeters. If the car is initially at 45 kilometers per hour and its mass is 850 kilograms, what would be the net force that would be required to cause this? So first I noted that this is constant acceleration motion. There will be a constant force we will apply briefly, and that's going to be the final speed minus the initial speed, 45 times 1000 meters per 3600 seconds, so we convert kilometers per hour to meters per second, divided by the final time tf, initial time is 0, so it's minus 12.5 over tf. Then we can calculate velocity as a function of time, v0 plus at. Constant acceleration motion, we can calculate the distance traveled, delta x, v0 plus at dt integral from 0 to tf, and set it equal to the diameter of a dime. So 6.25 tf, when we plug in the numbers, must be equal to 1.8 centimeters. So 6.25 tf equals 1.8 centimeters gives us the stopping time to be 2.88 10 to minus 3 seconds or milliseconds. So acceleration becomes minus 12.5 over this value, and the net force we have to apply is mass times acceleration due to Newton's second law. So that gives us, when we multiply this acceleration by the 850 kilograms mass, minus 3.69 10 to 6 newtons, a very large force is needed, which will cause deceleration of the car to stop in a distance equal to the diameter of a dime.